Welcome to Radiant Sky Solar Channel. I'm super excited to have you here. So in this video, we are going to be talking about solar panels, photovoltaic, PV, what you popularly know as PV, solar panels. We are going to be talking about how they work, what are the different materials that are used in producing them, and different types of solar panels you can deal with. Whether you are an engineer or you are an installer or you are an end user. Having knowledge about all these things will help you make decisions when it comes to solar panel. So you don't need to invent solar panel, you don't need to invent the material used in building solar panels, but understanding it will help you work with it and also know its roles in solar power system. So my name is still Engineer Truth. If you are new to this channel, make sure you subscribe, like, share this with your friend who is interested in learning solar energy for electricity. So we're adding more educative content for solar energy on this channel on regular basis. So make sure you stay glued and connected so that whenever we publish video, you get an update and be able to watch the video and learn one or two things from it. So let's get into today's video where we are going to be learning about solar panels, which is photovoltaic technology. So let's start with understanding what solar panel is, or photovoltaic, or how it works. So simply put, photovoltaic, popularly known as PV, refers to the technology that converts sunlight directly into electricity using special materials called semiconductors such as crystalline silicon. So what we are saying here is that there is a material used in building solar panels, and those materials has semiconductor fixtures. So if you know about semiconductors, so what they do is actually manage current and organize current when it comes to circuits or in anything electrical. So that is actually the work of semiconductors. So solar panels uses materials that have these semiconductors fixtures. That is what they are trying to say now. Now look at how a solar panel work, or photovoltaic. Look, this is how they work. When the sunlight hits the solar panel like this, the energy from the sun, like the radiant that the sun generates, it knocks electron loose from the semiconductor material that the solar panels are built with. So once that happens, those free electrons flow through the materials, creating an electric current known as direct current. So the current that is being produced by solar panels are known as direct current, DC current. And once this happens, so that current can be used to power electrical device. Actually, there are devices that operate in DC current, direct current, or it can also be used to, you can use it to store it on the battery, like charging the battery and all that. And all that also, you can also use other devices like inverter and all that to convert this direct current to AC current, which is suitable for household use. So with this, what you need to understand about solar panel is that it's made up of materials that has semiconductors fixtures, and that the current that solar panel produces are direct current, DC current, which also can be used to charge battery, or you store it on the battery, or use it to power DC electrical devices. So this is actually basically what happens in the process of solar panel technology, in the process of photovoltaic technology. So let's look at how this solar panel is being produced. So this is the production process of solar panel. So what we see here, what we see as a solar photovoltaic system installed in rooftop, in car stand, in different locations. This is how it's being made. Now you don't need to wrap your head around this, you just need to understand them. So as installer, as engineer, you're not going to be going into details producing panel unless you want to venture into that business. All you need to know is to understand, to understand how solar panel works, to understand how it's made, also know the different types. This is going to help you make decisions. So but with that said, let's briefly look at how solar panel are converted to these modules you see that are well arranged, structured in cells and all that. So when you look at the process of manufacturing solar panel, you see the material that is being used for it. So we have crystalline silicon, or also called polysilicon. This is the raw material used in solar panel manufacture. So in the process, this was crystalline silicon or polysilicon will be converted to ingot. This is more like converting it to a way that is going to be more transferable. So this ingot now can now be converted to wafer. So produce it to have a wafer design. Now this wafer design with other element that is mixed up, also with wiring, okay, to wire the current. They use a aluminum or silver element to wire the current from each of the cells. So they create a cells out of this wafer which has wiring. So at the end of the day, these cells now is going to be interlinked together. When you interlink them together, you have formed what is known as module. So module is a group of cells. Okay, so when you now connect all these cells, you now have a full solar panel, a full solar photovoltaic system ready for installations. Okay, this is the process of creating a solar panel. So with this said, let's look at the different types of solar panel. This is actually very, very important because the kind of solar panel you choose will determine everything about your solar system, will determine, okay, the numbers of solar panel you'll be needing, will also determine your performance of your solar system. Okay, so there are there are different models and types or in varieties of solar panel, but there are three major types of solar panels I really want you to understand, because you are likely going to come close working with all these types. So there are three major types of panel. We have monocrystalline solar cells. So we also have polycrystalline, okay, solar cells, panels. Okay, so we also have thin film solar cells or panels. So these are just telling you the different technology or the different processes to this panel. So we are going to go into take them one after the other to really understand them and their performance and all that. So let's start with the monocrystalline solar panel. I want you to really understand these types of panel. So when you are talking about monocrystalline solar panel, you are talking about a panel that is made from a single pure crystal of silicon. So what it's saying is that this panel, monocrystalline panel, are made with pure crystal silicons, no mixture, no other material mixed together to form it. Pure crystal silicon. Okay, so you can recognize mono panel with uniform black and dark appearance, just as you are seeing it now. You also, and edges, if you see the edges of this panel, you see that they are cut. So we are going to look at that later on. So what you should know about mono panel is that they are very efficient. Okay, they have up to 8 to 24% efficiency. Okay, they are also very expensive because they are efficient. They are more costlier than most other types of panel. Okay, so they also have a lifespan of 25 plus years. So if you buy a new mono panel, it's likely going to last up to 25 years. Very long lifespan. Okay, so another thing you need to know that is that it needs less space because of its efficiency. Okay, when you compare with other types of panel, when you are using 10 of other types of panel, you can be using like 7, 6, okay, or 5 of mono panel based on its efficiency. That is what it's trying to tell you, that you need less space. Okay, if you are using 10 panel that will accommodate, imagine 10 panel filling up space. Then if you are using 5, you know that you will use less space. That is actually what, because it's efficient, you use less of the panel. Okay, it also performs good even though the sun is not that too shiny and all that. You can still generate power with mono panels. That is the good thing about it. Okay, so with this said, these are the features of monocrystalline solar panel. So you need to also understand that mono panels comes in different types. You have a mono panel, but it has a different technology or a different model or the way it's created, just to make it more efficient and all that. So there are also types of mono panel. There are different types of mono panel you find out there. One of them is this preservative emitted and rare contact mono panel. This is called mono panel. So this is called PERC mono panel. So how is this one built? So this is a mono panel, but this mono panel is built with a material that allows it to preserve heat. Okay, this preservated material allows it to preserve it. How does this one work? So imagine this panel now has a material built with it that helps it to preserve heat. So when a sunlight, a radiation from the sun hits this panel, so instead of the panel absorbing the one it can and wasting other one, those material will help it preserve the entire heat, making it to generate more power. Okay, so that is actually how this one works. It's not a big deal, it's just the material that is used. Apart from the monocrystalline features of the panel, they also built in this preservative emitter or air contact to preserve the energy, to preserve the temperature or the radiations that the solar panel receives, making it produce more power and all that. So that is how this PERC monopanel works. Okay, it's just a technology that is added to the monopanel. So we also have what is called half-cut solar panel. So this one is a monopanel, but the way it's built, you see that it has two major cells with other small cells. So this also makes it efficient. So the way this panel works is, apart from having two major cells, they also have smaller cells. This actually makes it very efficient. Each of these, the two major cells are working independently, but at the end of the day they are giving one output. Okay, so as the cells are broken down here, so current flow easily, faster, and even more efficient. So this is half-cut solar panel. So when you see a full cut, this is an example of full cut. There is no demarcation. So an half-cut solar panel will always work much better than full cut monopanel. Half-cut monopanel will always work better than full-cut monopanel. This is just the technology, and this also makes it more efficient to build. To divide these cells, build them in these smaller particles and all that, it also makes it more expensive. So a half-cut solar panel is also going to be more expensive than full-cut solar panel. Just have this in idea. So this is more like another version of mono panels. Okay, so we also have bifacial mono solar panel. Now how does this work? Apart from also having half-cut, working with two major cells in tiny cells, this one also have the ability to absorb temperature, absorb radiant from the sun, front and back. I mean, this front can absorb radiant, this back also can absorb radiant, making it more efficient. Okay, it's no longer depending only on the front. That means if the sun, if the radiant land on this solar panel, okay, the front side will absorb all it can absorb. Then the heat coming out from under also can also generate energy that can generate electricity. So these are the different types of monopanel. So when you have monopanel, so you can have monopanel comes in bifacial, it can come in half-cut, it can come in PERC model. Okay, so these are all different types of monopanel, and to identify them is that it's very clear here. You see half-cut having demarcation behind it. You see bifacial, you see that the back of the panel will also be made up of glass, and also the front also, okay, to show you that it can absorb heat from both sides. And this for this PERC model, you see a kind of materials building around it. It can also be much heavier than other models. Okay, so that is basically how you identify all these types of model. Now let's look at the other type of solar panel. So we have polycrystalline silicon solar panel. Okay, also you can call it multicrystalline solar panel. So how is this one made? How do you identify this? So polycrystalline is made up of multiple silicon crystals melted together. So the way this one is built is that you can have multiple different types of silicons, materials and all that. They melt it together to form this. Okay, so if you look at how you identify it, you see that it's bluish, and also it's sparkled appearance. It's still like more like shining. Okay, that is how you, by merely looking at poly panel, you should be able to identify them with this identity. They are bluish in color and they sparkle in appearance. So when it comes to efficiency, it's moderate, 15 to 18%. It tells you that mono panel is more efficient than poly. Okay, so when it comes to also cost, is also lower when it comes to cost compared to mono panels. Okay, due to the way it's been made and all that. Also, the lifespan ranges from 20-25 years, and when it comes to space, mono panel is more space efficiency than poly, because if you are using 10 poly to power a system, 8 or 7 mono can serve that, because mono is more efficient. So that is basically, so when you are talking about space in that regards, mono is going to be actually space efficient than poly. Okay, so we also have it performing in low light. When there is no light, mono panels is also much better than poly panel when it comes to low intensity of light. Okay, so also when it comes to different types of panels, you can also see them in this PERC model, whereby they build in a preservative materials to preserve the heat that the solar panel received to generate more energy and all that. It's also possible you can find solar panel there. You can also find solar panel in full court. It's not demarcated. You can also find poly solar panel also in half court, okay, which also makes it efficient. So these are different forms you can find a solar panel. Now, how do you differentiate solar panel and mono panel, which is very, very much important? So in the field today, you are going to be experiencing these two panel. In fact, in country like Nigeria where we are, poly panel is now being outdated. Okay, what you find most out there is mono panel with different models I showed you, with that PEROC model, with half court, with bifacials, different types of model of mono panel. That is what you find there. But it's also necessary, okay, it's also necessary you know how to identify them, know them, so that you don't make mistake inside, so that you don't go order for panels and they supply you poly and you don't know how to identify it, or so that you don't get caught up in being able to identify which panel is when you are caught up on any time. So this is a mono panel. The different way, the easiest way to identify them is by their color. You see the color, okay, the wafer is always black in color, very dark black in color, and you see mono panel always having something like edge cut. This is how it's built. This is how the technology is built. It has an edge cut, okay, on the wafer. You see this design, like more like an edge cutting on them. But if you look at this poly, it is very, very shiny, okay. The is a rectangular design. Look at the cut here, very rectangle, okay. It's bluish in color and all that. So if you have been presented with these two panel, even though it might have a sticker at the back that will indicate what type of panel it is, but merely looking at it, you should be able to identify what type of panel they are, okay. So basically this is how you identify mono and poly panels, okay. So let's look at the other type of solar panel, thin film solar panel. So how is this one made? So thin film solar panels are made by depositing tiny layers of photovoltaic material on a substrate like glass, plastic, or metal, okay. So these are more like a flexible types of solar panels, okay. So one thing you should know about tiny film solar panels is that they are very flexible and lightweight, and often they come in black or dark color, okay. So efficiency, other poly and mono are always higher in terms of efficiency. They have more efficiency than thin films, okay. So they are also very low when it comes to cost, because the materials and everything in manufacturing is low. So they are low when it comes to cost. So their lifespan ranges from 10 to 20 years, okay. When it comes to space efficiency, okay, due to the way it's built, it has a very space efficient. This type of panel, because they are flexible and all that, they can be installed in a fence, they can be installed by, in a wall, different angles and all that. So other places or other locations where solar panels, installing a mono panel or other kind of panel can be a limitations. Due to the flexibility of thin film solar panel, it can be used in that situations. And also it's very, very good when it comes to low light performance. It can work very well with low sun, low temperature, or low radiation from the sun. So this type of technology is a new technology now that is evolving, so whereby solar panels can be easily installed along the road, by the objects and all that. Also, this technology is what is used by all these movable electronics, okay, radio, touch lights, all these things that uses solar power to charge, solar energy to charge the batteries they use and all that. This kind of solar panel is what is being deployed in building all those kind of technology and all that, okay. So these are the different types of solar panel, and I can tell you, if you are working on a site on regular basis, you are an engineer, you want to get your hands dirty on installer, you may hardly get across this panel. So what you will be coming across mostly is going to be the mono panel and the poly panel, and most times you are going to be working more with the mono panel. So pay attention, okay. So apart from these three major types of solar panels, so you may also come across other types of technology in terms of photovoltaic, okay. technologies. Okay, so we also have what is called concentrated photovoltaic system. This also can be used to generate electricity, but work differently, work with glasses, receptor and all that actually helps to generate power. Okay, this also makes use of cells, but in different way, in different technology. Okay, so you also have what is called roof ties solar panels. So today now, advanced technology is there that are building solar panel on a roof ties. Okay, now instead of buying a roof, after buying a roof you're also installing a solar panel. So you can just buy a roof ties solar panel and use it to roof your roof. Then after the roofing, you connect your solar panel, connect the wirings down to your system, connect to inverter or battery, and start charging and powering your house. All these things are new technology. These are different ways, okay, solar panels are involving. Though there are different technology also involving, people promising that solar panel is going to be transparent, it's going to be lightweighted, it's going to be cheaper and all that. But till then, okay, till then we are going to be working with what we have. We are going to be working with what is mainstream now, which is I'm going to encourage you to pay more focus or attention to the three major types of solar panel we explained earlier. Okay, so with that said, let's look at basic reading of solar panels. So I'm going to make a video subsequently to actually explain more about solar panel connections and also understanding the how you read solar panel both with your devices. But basically, let me explain how to really understand the capacity of solar panel, which is solar panel reading. When you buy a solar panel or when you come across a solar panel, okay, when you check at the back, you see a sheet like this, which is called data sheet. You see a sticker or a sheet like this giving you information about the solar panel. If you don't see it, your manufacturer is supposed to give you a manual where you find informations like this. Very, very important. This is the information you need to make choice on your solar panel. Both choice on the one to buy, both choice on the how you are going to make your connections, okay, to your other solar system and all that. This is where you get the information. If you get the information wrong here, you can actually cause disaster or make mistakes in the process. Okay, so when you look at this sticker here, this data sheet, it's telling you here that the wattage of this panel is 460, and you can see the sign of mono. It's telling you that this panel is a mono panel, monocrystalline solar panel, right? So pay focus on these descriptions here. So this peak power, I want to explain this now. The peak power here tells you that this solar panel rated wattage is 460. That is the peak performance. When this is the maximum power this panel can give, 460. Okay, power tolerance. Now this, they measure this in wattage. This power tolerance, whenever you see power tolerance on solar panel reading, what you need to understand is that it's telling you that there are some situations or intensity of sun or condition whereby this solar panel, though is rated 460, it can add up to extra 3%. Okay, that means if you times 3% of 460, it's telling you that there are conditions whereby this panel can read up to plus 3%. Okay, so if you do 3% of 360, anything it gives you, add it here. That means this panel sometimes can get up to 470 or 480 watt or so. If you say plus or minus, it's also tell you that this panel can go below 3% of 460. Okay, if you times 3% of 460 minus it, it's telling you that sometimes this panel can go minus 3% or plus 3%. So it's good to put this into your consideration. Okay, so if you are doing the calculations in terms of voltage, you are configuring a system with voltage measurement, so you need to put this into calculation. You may go and calculate 460, and let's say you have exhausted the space from your device. Let's say your panel can take up to, let's say, 1000 watts, or let's say your solar controller or inverter can take up to 1000 watts, and you have like 2 panels. Okay, so you now went, okay, and got 460. If you don't put this into consideration, let's say at peak performance this panel can surge up to when you add the 3%, it can get up to 510 or something. So if you see that, if that happens, you will exceed the maximum wattage of that device you are working with. So that's why you need to put all these things into consideration. Know how to use or configure your system going by the data they give you here. Okay, So another thing you need to understand is the maximum current. So current are part of the thing that solar panel produces, that charges battery, also that powers your house. Household appliances, AC and all that, they work with current. So solar panel can also produce current, and it's telling you this maximum power current. So when you connect this system, maximum power current is telling you that when you connect this solar panel to other systems, it's going to produce 7.67 amps. So that is the amps that is going to be working with when it's connected to other system. So it also has maximum power voltage. This is also telling you that when you connect this system, when you connect this panel to this system, to other system, maybe to charge controller or to inverter, or you connect with other solar panel, experimenting on different angles and all that, that the maximum voltage, the voltage is going to produce is 60. Okay, voltage is 60. Now short circuit current, now this, when you are test running this panel, maybe not connected to any device or anything, you can read up to 8 amps. Okay, but when it's in operation, you should be expecting up to 7.67 amps. Same thing, this is the open circuit voltage. When you are trying to test run this panel openly without connecting to other device and other stuff, this panel can read up to 72 volts. Okay, but when you connect it to a system and all that, you should be expecting up to 60 volts. Then if you are doing your calculation, it's actually good that you work with the higher volts. For example, if I'm calculating, okay, I have this panel 5 pieces, okay, I want to, and the maximum voltage I want to work with, okay, the system I'm working with, I should not put it, it should not have up to 200 volts, or it should not have up to 300 volts. Okay, so 300 volts. So you need to work with this. If you times this times 5 or times 6, let's say the number of panel you have, okay, you need to make sure that this thing is under control. It does not exceed the maximum voltage that any device you are working with this panel can power or can accept. So these are just basic information on the solar panel that you need to understand. So working with all this information also would depend on what kind of connections you are making, or what kind of device you are working with. Is it inverter? Is it charge controller? Is it an hybrid system? Is it an high voltage system? Or is it a normal voltage system? That would determine the connections you have to work with. But then you need to understand all these things I just explained. Okay, so if you also look down here, also we have the kg of the inverter, we have the dimension. Dimension is also very important. If you are trying to install a solar panel for someone and they decided to go with a car stand or build a special space for the panel to sit, you can use this measurement to construct that place. Then the maximum system voltage, this is trying to tell you, this is the voltage system, this is the voltage of the panel. It's trying to tell you anything you connect this panel, don't connect it, you do 72 times 1 times 3. Let's say you connect, regardless of numbers of panel you connect, don't connect the voltage to exceed 1005. That is their own recommended advice. Okay, so you also see all these things applicable, telling you the application class, fire safety C. So this fuse rating is something I want to explain to you. So we have an amp here. The amp this solar panel can produce is 7.6. On the short circuit it can produce 8. So something can happen, there can be over current flow or whatever. Okay, what this is trying to tell you, this fuse rater tell you that whatever happens, that this panel has a fuse that can handle over current or whatever, to make sure that it doesn't get to spoil something and up to 20 amps. So this is actually very great. This is a great technology. It makes it up. Whatever happens, your circuit current, your current, the solar panel generated a current and is packed up, okay, exceeded the amount it's rated here. The panel has the ability to manage it as far as it doesn't exceed 20 amps. That is a good features on it. So these are some of the things that make solar panel more safer. So it doesn't get burnt easily and all that. It's the help of this technology fuse on it rated. So one thing you also observe here is that this panel is also tested under standard test condition. So the standard test condition is 1000 watt per square meter, which is the radiancy that reaches the earth area. Okay, so these are the conditions where this solar panel is tested, and they are trying to tell you that the height of the temperature on which this panel is tested, to give you all these details, is 25 degrees Celsius. So these are just basic panel reading. This helps you make decisions on connecting your panel, and also the size of panel you should use, and also the the quantity of panel you should use on your system. Okay, so basically that is it about solar panel. So that is it also about reading your solar panel, the data sheet of your solar panel. So that is it for this video. So we have talked about types of solar panel, what solar panel is all about. Okay, we talked about solar panel being made of crystalline silicon materials that have semiconductors that can conduct current. When the sun hits the silicons, they release electron generates current, DC current that can power house. I also mentioned that we have three types of solar panel. We have monocrystalline solar panel, we have monocrystalline solar panel, we have thin film solar panels. So these are the different types of solar panel. So that is it. Thanks for watching this video. I hope you get one or two things from there. So if you have questions or you have any comments on this video, please drop it below the video. Okay, so make sure you are subscribing, because we are going to be talking more about solar panels. We are going to be talking more about solar batteries and inverters and all that. So that is it for this video. Thanks for watching, and I will see you in the next one. Bye.